Welcome to all. Myself T. Muthukumar, Assistant Professor, Department of Electrical and Electronics Engineering, Kungunadu College of Engineering and Technology. Today, I am going to deliver a topic on power electronics subject. So, in this, characteristics of SCR, going to discuss in this session. Before that, I am going to give some introduction about what is power electronics, applications, advantages of this power electronics. Power electronics, so it is a field discussed with the applications of solid state electronics for control and conversion of electrical power. So we need for the power electronic devices, that is power switching devices for the conversion and control of electric power. So power deals with the generation of power equipment, generation of powers using the rotating electrical machines. So under the generation, transmission, and distribution. Electronics deals with the solid state drives and devices and circuits for the signal processing to meet the desired power outcome. Control deals with the steady state and the dynamic characteristics of closed loop system. So power electronics means, so we are going to use the power electronic devices or power switching devices to control and the conversion of electrical power. So next, history of power electronics. So history of power electronics started in the year of 1900. So with the invention of mercury arc rectifier. So later, so a lot of inventions are made by the scientists. So between the 2900 and 1950, so metal tank rectifier introduced in the market. Ignitron will be introduced, panatron will be introduced, and also thyratron will be introduced. So further, 1948, silicon transistor will be introduced. So 1956 is a important revolutions in the power electronics. So thyristors or silicon control rectifier comes into the market. So in the year of 1958, commercial thyristors are comes into the market. These are the history of power electronics, the applications of power electronics. So power electronic devices used for UPS, uninterrupted power supply, and standby power supplies for computers and medical equipments. So power conversion for HVAC, HVAC and HVDC transmission system. So speed control of motors. So with the help of traction drives, textile mills, rolling mills, vans, lift and pumps. And the power supply for the communication purpose, that is telephone communication and satellite communication purpose. So advantage of power electronic controllers. So these devices have the fast dynamic response due to the static devices, and also higher efficiency of conversion. So losses will be reduced, size in compact and lightweight of the controller. So operating life will be increased, the maintenance will be less. Disadvantage. So it generates the harmonics. So these harmonics affect the performance of the converters. So power factor also low, hence power factor correction is necessary to reduce the reactive power power. So very simple conversion technique. So power electronic converter may be costly. So cost wise it is high. So this is the general block diagram of power electronics. So in this, so power source. So this is our power controller. So it is made up of power switching devices, that is power semiconductor devices. So it provides the required output to the load. So output voltage again get from the feedback. This is given to the control circuit based on our requirement. So this control circuit going to adjust the switching pattern of the power converters. So finally we get the required output voltage or output from the power electronic converter, the help of power electronic converters. So types of power electronic converters. So first one is AC to DC converter. So input is AC, output is variable or fixed DC output. Second one is DC to AC converters, that is called inverters. So fixed DC voltage to variable voltage, variable frequency AC output. So third one is DC to DC converter, that is choppers. Input is DC, output may be fixed or variable DC output. So next, AC to AC converters are called cycloconverters. Fixed voltage frequency AC supply is the input, variable frequency variable voltage is the output. Last one is AC voltage regulator. So input is fixed AC supply, output is variable AC output voltage. So these are the different types of power converters. So next is the classification of power devices. So generally it is classified in three types. One is a diodes, so thyristor and a transistor. So comes under the diode, general purpose diodes, high speed diodes and Schottky diodes are there. So this is the uncontrolled devices. So thyristor, so in thyristor family, so more number of devices are SCR, GTO, RCT, SITH, gate, light activator SCR, MCT and triac. So next one is transistor. So transistor, BJT, MOSFET, IGBT, SIT. So these are the basic power devices or switching devices. So in this, I'm going to discuss silicon control rectifier. So it is one of the thyristor family. So SCR is silicon control rectifier, GTO gate turn off thyristor, RCT reverse conducting thyristor, static induction thyristor, SITH, gate assisted turn off thyristor, light activated silicon control thyristor, mass control thyristor, MCT, triac. So in this combinations, so SCR is most commonly used, that is called thyristor is most widely used power electronic devices. So these are the basic symbol and the construction diagram of SCR. So SCR is a silicon control rectifier. It is one of the thyristor family. It has three terminal, anode, cathode, and a gate. So here gate is used to control the output voltage. Output. So this three terminal device also has three junction J1, J2, J3. It is a three terminal, three junction, and also it has four layer device, P type, N minus, Pn, and P plus. These are four layer devices. So it is a three junction and four layer device, and also three terminals are there, anode, cathode, gate. Gate is the control signal. So merits of SCR. That is advantage. Very small amount of gate drive is required since SCR is regenerated circuits. So we are going to give the minimum amount of gate voltage to the SCR. So it will be turn on. So next SCR, the high voltage and current ratings are available. So compared to the normal electronic circuits, so power devices have high voltage and current ratings. So SCR have high voltage and current ratings. And the on-state losses in SCR are reduced. Merits, that is disadvantages are the gate has no control. Once SCR is turned on means, so gate has no control. So we need for the turn off circuit. So external circuits are required to turn off the SCR. Operating frequencies are very low. Sember circuits are needed for product dV by dt production. Applications. Generally, SCRs are used for the silicon control rectifiers. That is control rectifiers going to control the output voltage with the help of gate signal, AC voltage regulators, lighting and heating applications, DC motor drives, and the large power supplies, and the electronic circuit breakers. These are the applications. So SCR characteristics and modes of operation. So it has three modes of operation. One is reverse blocking mode, forward blocking mode, forward conduction mode. So first one is reverse blocking mode. So it is also called reverse biased SCR. So in this case, so positive voltage is given to the cathode terminal. So gate is given to the P-type material. So positive supply of the power supply is given to the cathode terminal, and negative is supplied to the anode terminal. So cathode is positive with respect to anode. So with the help of these connections, J1, J2 are the reverse bias, and the J2 is forward bias. So in this state, so very small amount of reverse current is flowing across the anode to cathode. So it is a reverse blocking mode. So next state is forward blocking mode. So in this, anode is given to the is connected to the positive supply, cathode is connected to the negative supply. So in this case, it is called forward bias condition. Positive supply is applied to the P-type material, that is forward bias. J1 and J2 is a forward bias, J2 is a reverse biased. So gate terminal is going to control the output voltage. So in this case, very small forward current or leakage current is going through anode to cathode. So last one is forward conduction mode. After reaching the forward blocking mode, so here is a forward bias. It is goes to the forward conduction mode by the following ways. When VAK is greater than VBO, that is anode cathode voltage is exceeds the breakover voltage means, so automatically SCR will be in the conduction mode. So next type is when gate is applied. So we want to apply the gate signal. So third one is when dV by dt exceeds the permissible value. Last one is when gate cathode junction is exposed to light. So these are the turn-on methods of SCR. VAK greater than VBO, gate reverse is applied, dV by dt exceeds the permissible value, when gates cathode signal is exposed to the light. So these are the VA characteristics of SCR. This diagram shows the relationship between the voltage and the current. So in exercise we are taking the anode cathode voltage, that is VAK. So y-axis current, anode cathode current. So this is a voltage current characteristics curve. That is called VA characteristics curve. So this is called reverse blocking mode. So in this reverse blocking mode, your reverse voltage is applied. So very small amount of reverse leakage current is passing through them. Almost it is in the off state. So if reverse voltage exceeds the reverse breakdown voltage VBR, so its reverse current goes very high. So after VBR, current increases rapidly. So this is the reverse blocking mode. So if the forward voltage is applied to the anode cathode terminal, so very small amount of forward breakover voltage is very small leakage, forward leakage current is flowing from C0 to some values. So after this forward leakage current reaches the VB naught. So VB naught, that is breakover voltage, forward breakover voltage. Our anode cathode voltage exceeds the forward breakover voltage means, so automatically, so IAK, that is anode cathode current is increases rapidly, depends upon our gate signals. So this is called forward conduction mode. So in reverse blocking mode, diode in off state. Forward blocking mode also, very small amount of current flowing through the anode to cathode, and only forward conduction mode the SCR will be turned on. So here we are applying the different gate signals IG1, IG2, IG3. So based on that, the conduction will be happen. So conduction only happen after the forward breakover voltage. So two important currents are there. One is latching current. So latching current is the minimum forward current that flows through the SCR. That is minimum forward current that flows through the SCR to keep it in forward conduction mode, that is on state at the time of triggering. So if forward current is less than the latching current, say SCR does not turn on. So forward current should exit the minimum forward current is called the IL, that is called latching current. So next one is holding current. This is the minimum forward current that flows through the SCR to keep the SCR in the forward conduction mode. So when forward current reduces below the holding current, SCR turn on. So we want to maintain minimum current, that is holding current, to maintain the SCR in the conduction state, otherwise it is in off state. So these are the characteristics of SCR. So I'm going to conclude my session. So SCR is one of the important device in the thyristor family. Depends on the advantages. So it is a 4-layer device, 3-junction device, the 3-terminal device, anode, cathode, and gate terminal. So gate signal is going to control the output voltage. With the help of the controlling the gate signal, so we are getting the required output voltage. So modes of operation are forward blocking modes, reverse blocking mode, forward conduction mode. So if positive supply applied to the cathode means that is a forward blocking mode. Very small for reverse blocking current is passing through the and forward blocking modes, positive supply is applied to the cathode. Sorry, positive supply is applied to the anode. Very small forward leakage current is passing through the anode to cathode. So after the PAK exits, so VBO, then only the SCR goes into the forward conduction mode. So it has more advantages. So it is used in the controlled rectifiers, power supply conditions. Okay, this is the VA characteristics. So in reverse blocking mode, so it is almost in off state. In forward blocking, very small forward leakage current is passing through the anode to cathode. So after the VBO, so current increases rapidly. That is called forward conduction mode. That is the on state. Okay, thank you.